6. hafta laboratuvar dersine hoş geldiniz. Abbas hocamız şey yapacak. Anlatımı teşekkür ederim şimdiden yapacak. Herhangi bir sorunuz olursa ben tekrar bağlanacağım. Buralardayım yani. Teşekkür ederim Abbas hocam. Buyurun. Ben kaydı başlattım hocam.
Sağ olun hocam. Emre ve Mehmetcan var.
Siz de sağ olun hocam.
Sağ olun hocam. Emre, sesim geliyor değil mi? Emre ya da Mehmetcan, sesim geliyor değil mi? Tamam. Teşekkür ederim arkadaşlar. Biraz feedback'e ihtiyacım var. Şimdi geçen hafta ne yaptık? Kısa bir Türkçe hızlı anlatalım. Add with carry vardı arkadaşlar. Subtract with borrow vardı hatırlarsanız. Bir tane carry flay'imiz var. Bu carry flay'i dikkate alarak yaptığımız toplama işlemine add with carry, carry flay'i dikkate alarak yaptığımız çıkartma işlemine subtract with borrow diyoruz. Basit örneklerdi. Trikli bir soru vardı. 32 bit 2 tane sayı, unsigned tam sayıyı nasıl toplarız, nasıl çıkartırız gibi 2 sorumuz vardı. 3. sorumuzda da bunları karşılaştırma, hangisi daha büyüktür, karşılaştırmasını nasıl yaparız karşılaştırması vardı. Biliyorsunuz ki 8086 mimarisi 16 bitlik bir mimari olduğu için 32 bitlik bir işlemi yapamıyordu. O yüzden 16 bitlik parçalar halinde yapıyorduk. Bu iki parçanın arasında bir elde verme, elde alma durumu olursa onu carry flag'le hallediyorduk. Add with carry ile kullanarak ya da subtract borrow kullanarak carry flag'le 2 16 bit arasındaki 1 bitlik eldeyi veriyorduk. Geçen haftanın konuları bunlardı. Bu haftanın konusu Stores byte, stores word, loads byte, loads word, moves byte, moves word, clear direction flag, set direction flag ve repeat, rep instruction'lar olacak arkadaşlar. Çok fazla gibi gelebilir. Bunlar zaten çiftli byte ve word kombinasyonları. İşte bunlar store ediyor. Yani memoriye yazıyor. Loads'lar memory'den okuyor. Moves'lar memory'den alıp memoriye yazıyor. Sadece kopyalama işlemi yapıyor. Bu direction play'i set etme, clear etme ile alakalı basit instruction'lar. Rep dediğimiz, yukarıda bahsettiğimiz komutları, stores, loads, moves komutlarını tekrarlı çalıştırmak istediğinizde önüne şu kadar tekrar et der gibi CX'in içine koyduğumuz sayı kadar tekrar etmesini sağlayan bir komut. Aslında bu haftanın konusu bu kadar. Dersimiz de burada bitti demiyorum. Bitmedi. Yeni başlıyoruz. Evet, şimdi İngilizceye geçiyorum arkadaşlar. Bakalım kaç kişi var önce bir. 5 kişi burada görünüyor. Elmas, Emre, Enver, Mehmetcan, Bilge, Kaan. Okay, my friends. Today's topics are string operations. Actually, the original name of these instructions are string operations. When you go to emulator help, let me open the emulator help and open tutorials. Under the tutorial, there is what was that? Interrupts, library of arithmetic logic instruction, procedures, not these ones. Numbering stem, procedures, no. Moves, no. There's no tutorial about this string instruction. Actually, there should be instruction set, memory table, custom memory table, IO ports. There's no string. Okay. There's no tutorial about string operations. Let me moves byte. Yep, no. Never mind. Okay. We have instruction set. Let's first see this clear direction and set direction. These are very straightforward commands. clear direction flag. It's all it is doing. It just sets the direction flag to 0. We are going to use it. For example, if we open the flags, the default value of direction flag is 0. 0 means forward. Forward means increase. I'm going to cover that later. If the direction flag is 1, which means backward, backward means decrease. Okay, going down means increase in number form, and which is forward. Going down, going up means decrease, which is backward form. You only need to know this. Direction flag is this. With CLD command with no operand, just using CLD command, you just clear the direction flag. With STD command, we set the direction flag. Let me open the flags for you. Please look at the direction flag in here. Direction flag is now 1. Direction flag is now 0 because one of them is set, one of them is clear. Okay, let's go over to the document. Okay, we have repeat command. I'm going to cover that later. Let's start with stos byte. Okay, we have instruction sets. All of the instructions are here. Let me open the index again. Instruction set. Within instruction set, we have these tools, stos byte and stos word. They are same. Only difference is one of them is using byte, the other is using word. Okay. Algorithm. Algorithm is this. Let me paste this into text document. Store byte in AL into exasegment destination index couple memory location. Okay, we have a couple, exasegment destination index couple, and we have a value in AL. Let's put some value into AL, like 73H. And I want to store this value into memory with stos byte command instruction. Stos byte instruction doesn't take any operand. You only use it like this, and this is the program. But stos bytes operand automatically look for exasegment destination index couple to save it. So this is legitimate code. Let's see where it stores the 73 into memory. We have 73 into AL. We run the stos byte. Stos bytes look for the exasegment destination index couple. Exasegment destination index couple is here. As you can see, it's 1000. It writes 73 into there. So we need to change this destination index and exasegment parts in order to store in correct location. Let's say I want to store the value into 2000 H address. As you know, this is 2000 physical H address. Physical. Okay, I want to store in 2000 H address. That's why I'm going to update destination index with 1000 H. An exasegment is already 100, but let's use BX, not AX. 100H in BX and update the exasegment with BX. Okay, we update exasegment to 100 and destination index to 1000. So this program take this AL value and put it into memory with stos byte value. As you can see, exasegment is 100, destination index is 1000. When I go to 100 and 1000 memory location, which is 2000 physical address, as you can see, 73 is stored in there as a byte in a single line. Okay, now I'm going over and looking for the stos word. Stos word. It stores word Let me copy this algorithm. These are X commands. We have loads X commands and moves X commands. Okay, the algorithm, this time algorithm looks for a word. It means it takes AX and put it into exasegment destination index address, update the destination index. Okay, let's go over our example. Now we have 1173 16-bit number in AX, and we want to store this value into 2000 physical address, starting from 2000 physical address. And I want to just update this with Word. This is a simple example. AX is 1173. We update exasegment with 100, which is already 100. Destination index is 1000H. Yes, destination index is 1000. So exasegment destination index couple is 2000. Let's go over and look at the 2000 location. As you can see, word value of AX 1173 is copied into memory as like this. Okay. By the way, stores byte and stores word increase destination index automatically. We didn't increase destination index. It increased itself. I'm going step back and look at the destination index. It's 1000. When I go forward a single step, it becomes 1002. In stores word is a 16-bit, remember. Every memory location in this line, every line is 8-bit, which is byte. So a word updates destination index by 2. But stores byte updates destination index by 1 because it just copy byte, the other copy word. So destination index needs to be updated according to size. Okay. Now, the direction flag is important in here because algorithm says that if the direction flag is 0, then it increases the direction flag, destination index. If the direction flag is not 0, it decreases the destination index. Okay? So within this example, direction flag is 0, so it increased the destination index into 1002. Let's change the direction flag into 1. Remember, this set direction flag into 1. I'm going to open this here. Go one by one. STD updates the direction flag into 1. Okay, now stores word is going to save the AX into exasegment destination index couple. It is the same location, which is 2000H. This will run. The memory is written into here, but destination index is decreased this time by 2. 1000H minus 2 is FFE. Okay, I'm going back and forth. Please look at the destination index. It's 1000 and FFE. Okay, so according to flag, stores word, loads word, moves word, these string operations update the source index and destination index according to size, if it is forward or backward, according to case. So, I'm going to call stores word again. What will going to happen? Okay, we have AX 1173. We change the exasegment. Destination index is 1000. And we set the direction flag backwards. Direction flag is now 1, which is stating backward. which means destination index will be decreased. We run the first STOS word and it is written into 2000 address. Now I'm calling STOS word again. STOS word looks for the exasegment destination index couple and put the AX value into that memory location. Exasegment destination index couple showing this memory location. Okay, so calling again STOS word will write 1173 into here. I run it again. Let me go over and look at the memory. As you can see, 1173 is written backward into memory. Not written backward, but written previous word of 1000 memory address because destination index is decreased. Okay, let me update this code with clear direction flag. Direction flag is already cleared, but in order to be sure, let me use clear direction flag. Now what's going to happen? We are going to store in 1000 memory address, which is 1173. Another STOS word is also stores in 2002. Why? Because exasegment destination index couple shows the location of 2002. It will return into here. It didn't run yet. Yep, 2002 is updated with 1173. By the way, destination index is increased again. By just calling STOS word, destination index automatically increase. Any questions so far? Any question about anything so far? So no question. Okay. This is STOS word. Let's go over and look at the other example, loads instructions. Where is loads? Let's start with loads byte. Here's the loads byte algorithm. Let me copy it into here. It gets a value from memory into AL. This is strict. You can't change AL. It uses A register in order to store or load or move. So you can't change A. It is written directly. Algorithm is this. Data segment source index couple is calculated. The physical address is calculated. And the byte value of that memory location is copied into AL. Okay? And according to flag, the source index is updated. Either it is increased or decreased according to direction flag. So there is no operand. Loads byte is same. Let me put some value into 1000H address, which is 2000 physical address, and update data segment and source index. I want to read a memory location with loads byte. Okay, let's emulate this one. Okay, 1000 touch memory address has the value of 1173. We put it there. So let's say that memory location has some value. Currently it is 1173. Okay, we update the data segment with 100 in order to use loads byte. We update data segment, which is already 100. We use source index as a index operator because data segment source index couples are used in loads commands. And source index is updated to 1000 and loads byte command. loadbyte command calculates the data segment source index couple, which is 2000 physical address, and get that byte value into AL. As we can see, AL is 73. When I go over and look at the 1000 memory location, which is physical 2000, it is 73. It just copied the 73 into AL. Okay. Now I'm going to call loads byte again. Loads byte, as you can see, it gathers the 2000 physical address, which is 73. When I call again, this time data segment source index couple shows the location of 1001, which is 11. It will gather the 11 value into AL, and AL will be updated with 11. As you can see, AL is now 11. The previous 73 is lost. Okay. So when I update this code with loads word instruction, gather the 16-bit memory value from this memory location, data segment source index memory location, and copy it into AX, because this is word. It uses a word register and updates the source index according to direction flag. Okay, go back our example, simple example. This time we have 1173 in 1000 physical address. We use data segment as 100, source index as 1000. We are going to use loads word. It will get the word value starting from 2000 physical address. A word is a 2 byte. Remember, this 2 byte is a word, and we'll copy it into AX. And as you can see, AX is 1173. When I run this code again, what is going to happen? What will be the AX value? I'm opening the memory. What will be the AX memory? Any idea? What will be the AX memory after this first loads word? I'm going to run the second one, and the AX will be updated. I'm opening the memory. This is the 2000 physical address. Data segment source index showing at some position. It will copy it into AX. What will be the AX value? This is my question to you guys. Any answer? This is actually pretty straightforward, because loads byte, loads word, remember, looks for the data segment source index address. What is the data segment source index address? It is 100 and 1002. 100 and 1002 is the location of 2002. A word value from here will be copied into AX. So AX becomes 0. 0, 0, 0, 0. This is a word value. Okay. Okay, loads word is also covered. We have moves part. Let me copy the loads word also. Okay, moves comments. Moves comment also is a byte and word. Let me open moves bytes, moves word. Yeah, moves byte. A little tricky, but it's also a useful command. Let me copy what moves byte is doing. It's a byte operation with no operands. It copies a memory location value into some other memory location value. What are those memory locations? It is data segment source index into exasegment destination index. It finds the data segment source index value where these indices showing, copy that value and put it into exasegment destination index address. Remember, I want you to remember, in moves command, there was no memory to memory copy. You can't just copy this value into this memory location. Moves command doesn't have memory to memory operand. Remember? But moves byte operation is exactly doing this. It's copying this memory location to this memory location. So let's use moves command. Let's say 1000H address has 1173H value, and I want to copy this value into 3000 physical address. What I'm going to do, this is data segment source index couple. Data segment source index, and I'm going to use exasegment destination index. Let's say 2H. This location is 100, 000, 2000H. Physical address is 3000H. I want to copy a word from here to here. Let's say first byte, not word. I'm calling moves byte. With a single command, I copy a memory location from here to here. Okay, 1000H has the value of 73. Next. Exasegment and data segments are both 100. We do not update them. They are already 100. But we have source index and destination index. One of them is 1000, the other is 2000. Moves byte will calculate the location of data segment and source index, which is 2000. Get the 73 and put it into exasegment and destination index couple. Exasegment is 100, destination index is 2000, so physical address is 3000. When I run this moves byte command, it will copy the 3000 physical address has the value of 73. Okay, this is byte. Let's use another example. Let's put 1173H into 1000H memory address, starting from those memory address, and copy a word. Copy 1173 altogether. This will copy it into 3000 and 3001. 1173 into exasegment destination index bar. Moves word command, please be careful. Update source index and destination index. Both. Remember. Moves word command, update moves byte or moves word command, update source index and destination index both at the same time according to direction flag. So, rep command. What is rep command is doing? Let me write a simple example. I'm going to put some value into AL, which is 73, let's say. I want to store this value, which is stos byte, remember. In order to use stos byte, I need to define, let's go over and look at the stos bytes. Exasegment destination index couple. Exasegment is 100 already. Destination index is 1000, let's say. I wanted to copy this 73 into 1000, 1001, 1002, 1003, all of those memory location. When this comes, we can use rep command. Rep command runs cx times. So I'm going to run this 10 times. No, let's say 5 times. I'm going to copy 73 into 1000, 1001, 1002, blah blah to 1005. And I want to do it without creating a loop by just using rep command. Okay, let's emulate. AL has 73, destination index is 1000. We have 5 in CX. Now STOS byte is run. Let's go over and look at the 1000 location. It didn't written there because it didn't run yet. Yeah, 2008 address has the 73 value, and this repeat command runs several times, exactly 5 times actually. It runs 73, which is AL value into these 5 locations. So repeat command repeats the 6 instructions of these loads, stores, and moves combinations. Those 6 commands can be repeated with repeat instruction. Okay, you can't repeat any other instruction. You can't use rep add or rep increase, etc. You can only rep these 6 instructions. By using counter register again, which is CX, we put some value into CX and rep command runs CX times. And CX is decreased automatically by rep instruction already. Okay, so we cover rep and all the topics are covered. Now we need to dive into examples. Any question about anything so far? Any question? Okay. Yok gibi. Varsa sorabilirsiniz arkadaşlar. Biraz hızlı anlattım gibime geldi çünkü. İkinci öğretimlere anlatınca hızlı oluyor. Birinci öğretimde bu dersi tekrar anlatmış olmuyorum. İkinci öğretimde tekrar anlatmış oluyorum. Biraz daha hızlı oluyor. Gözümden kaçabilir. Birinci öğretimlerin ders kayıtlarına erişiminiz varsa oraya da bakmak isteyebilirsiniz. Aynı şeyi anlatıyorum ama belki biraz daha ayrıntılıdır. Evet. Examples. First example. Write a program that stores value of BCDE. Store this value into memory location, memory range of these between addresses. Okay. We need a value. I'm going to put this value into AX. Okay, here is the question. Can I put this value into AL? Which line is correct? Any idea? Come on. One of these lines is incorrect. And the second line is incorrect because BCDE is 16-bit value. AL is 8-bit register. You can't put 16-bit value into 8-bit register. Okay, so this is wrong. By looking at the value, I can directly understand that I am going to use an X register. So I'm using AX because I'm going to store value. So that's why I'm going to use STOS words stores word use the AX. Remember, stores word use the AX and store the AX into exasegment destination index address. That's why I'm going to use AX. I put value into AX. Then I need to update destination index. Okay, where's the PDF? Okay, location is 100 and 300. Exasegment destination index. Okay, location is 100, 300H. These are exasegment destination index addresses. I'm going to update only the destination index because exasegment is default 100. Put 300 into destination index. And I'm going to call stos word. Run this code. AX has the value of BCDE. And we have updated the destination index with 300. Run the stos word command. Stos word command stores the value into 1300. BCDE. But the question wants us to store this value between this range. All of this memory range will be filled with BCDE value. That's why I'm going to run this stos word repetitive. How many times does this stos word needs to run? Any idea how many times does this stos word needs to run in order to cover this range? From 300 to 3FFH. Ranges here. Ranges here. How many numbers between these memory ranges? There are FFH numbers. So since we are working with words, we need to divide it by 2. FF or 100 divided by 2. 100H divided by 2 is 80H. That's why CX needs to be 80H. Okay. So this stos word will run 80H times. Let's see if this is correct or not. I'm going to run this command a little bit. Okay, let's go over and look at the memory location. Yep, it's filling the memory range with BCDE values till this CX becomes 0. And then we go and look at the 3FF address. BCDE values are filled with. Okay, the first question is this. The answer to the first question is this. Second question, second example. Write a program that reads values between, again, same memory range. Subtract 1, 2, 3, 4H from these values and writes results back to the same address. Okay, we need to load memory, make subtract operation, and again store. So after these commands, we need loads word, subtract operation, and stores word. Right? In order to work with loads word, I'm going over and look at the loads word. Loads word used to this data segment source index with AX. Data segment source index will be stored in AX. Data segment is 100. Source index needs to be updated with starting position of this memory range. After above instructions, destination index is updated. That's why we need to update destination index again into 300 because we are going to store the value into there again. Loads operation loads the data segment source index into AX. That's why I need a subtract instruction, because question wants to subtract 1, 2, 3, 4 hash from every word within this range. Subtract operation, after that stores word using destination index will store the value back. But this will only run one times. Let me show you by running it. Okay. Let's go and look at 300. The result is AA. AA means B, let's put it into hexadecimal form. BCDE minus 1, 2, 3, 4 is AAAA. Okay, the result is AAAA, but the other values is same. Why? Because this tree line is run only once. We need to run this 88 times. You can't use rep like this. Every repeat instruction will repeat this into itself. Let me show you. I'm going over and look at the value. BCD, BCD, nothing is changed. So this is wrong. You can't rep the block. If there's a block to be repeated, you need to create a loop. Okay, remember, loop keyword with a label, whatever you define. This loop is run CX time, remember, it is 88 times. So it loads BCD into AX. Let me go over and show you. Okay. Loop start with loads word. Loads word gets the value from data segment source index. Data segment source index showing somewhere. The value gathered into AX and makes subtract operation into AX. The result is AA. AA is now stored with toss word, which is using hexasegment destination index. And this way, all the values are subtracted from 1, 2, 3, 4. Let's go over and look at the result. As you can see, every value is subtracted till FF. Okay. So this is the second question. This is the first question. This is the second question. Let's go over to third example, third question. Write a program that reads values between, again, same memory location, but this time read memory location and write these memories values into another location. So this is a copy. There's an array of memories. I want to copy this array into somewhere else. So we are going to use moves words. It's pretty obvious, I think. Moves words instruction, copy the data segment source index into, let me paste it in here. All of those data destination index, source index variables are updated. That's why I need to update those to starting point again. Okay, the starting points are here. Data segments are, hexasegments are same, but this time we are copying value from here to here. Destination is different. Destination is 3000, 3500. Destination index is 3500 H. So this moves word will run 80 times again. We need to put this into CX, hexadecimal, and run this single line of moves word command repetitively. Okay, so this is the third question. That's it. When we emulate this code, the first question is emulated, second question is emulated, and the third question is emulated. Now I'm going and looking at the 3500 location. The physical address is 4500. All of the memory is copied into here. It's still, by the way, there. The original location is, remember, here. We copy the memory array to another array. The two array is still available. Memory location stores the original values still. So this is the third question. As you can see, question may look hard to you, but the answer is pretty straightforward. Be careful, I don't use these default data segment, hexasegment values in the exam. That's why you need to beforehand update the data segment. For example, I'm going to use 200. In this case, let's say data segment is 200 and hexasegment is 300, for example. So be careful. If you didn't update segment part, these moves or stores or loads will not work correctly because it looks for the combination of data segment, source index, hexasegment, destination index couples. Okay? So any question about anything? We have updated source index and destination index again, not just because the destination is different, because the source index is updated with second question. Second question use the source index. At the end of the second question, source index is in here. Source index is 3FF. So if you use source index directly, it will use 3FF. Let me show you that. Let's use direction flag and use backward operation. Okay. In the first question, we start from 300, goes one by one. At the end of this question, source index, at the end of this question, destination index is 3FF. So let's go backwards without updating destination index. I'm going to use set direction flag and I'm going to update source index with 3FF. Starting from 3FF, I'm going to use word by word 3FF or 3FE. It's 3FE. It will copy 3FE and 3FF. Okay, it will run 80 times, but this time it will go upward. Okay, starting from here, destination index is here. It will decrease. Okay, let me put some lines in here. The first question. Second question. First question finished in here. I'm going to calculate in backwards. At the end of this code, the source index becomes 300. Let me delete this data segment part. Source index is already 300. Destination index only need to be updated. Yeah, that's it. First question goes this way. Second question, we set the direction flag and go backward. We need to go forward. Before this third question, we need to clear direction flag. So that it will go forward again. Let me emulate this one and see if it's true or not. Okay, let's go over and look at the. There are minor errors, but generally it's true. Let's see the FF. Oh, the last location increased. Why it increased? Last location. The first location, let's go over and look at the first location. First location is not used. So within the backward, this is forward, this is backward. Backward starts from 3FE. So this is the wrong part, I think. It will not be 3FE, it will become 400. Let me stop here. 300 is not true still. 300, the last part, the last location. Because it was going backward, the last location is not covered. So ATH is not enough. I'm going over and look at the 3FF. There's minor something wrong. Let me emulate this one again. Run this one. Stop at the next location. I'm debugging right now. I'm going to look for the destination index address. CX is 2, 1, and 0. For now, destination index needs to be, oh, it's 400. I say it's 3FFH. So destination index is 400. Before diving into here, I need to decrease destination index once. But that will increase my code. Set direction flag, decrease destination index. Run this code from 3FE. Emulate fastly. Now go and look at 300. We have a single byte error. Single byte overflow. I think it's because this E. Okay, let's say not EF. You can debug your code like this. All the calculations are misinterpreted. So it should be FE, destination index is 400. Oh, this will only decrease one time. We are working with words. Yep, it need to be decreased twice. Will be the correct version. Yeah. Let's look at the last part. Last part is also correct. Yes. So this will increase, and at the end of this loop, let's see the result if it's correct or not. By looking at 3FFH, there is one word is missing. One word is missing at the beginning. At the end, there is no missing. So this is runs correct times, but missing line, 0. At the end of this second question, the destination index and source index is increased into something. What? CX is CB8987654321. At the end of the second question, source index is 2FE, destination index is 2FE. We say 300. So beginning of this, we need to increase source index twice or add 2 to source index. Yep. This is the final code using direction flag forward and backward. Let me go over. Yep, this is the correct one, starting from correct position. Yep, till the correct position. Okay. So the first question starting from 300 goes forward, the second question goes backward, third question goes forward. Okay? I will not going to publish this code. In order to understand the direction flag and usage of forward and backward, you need to watch this video. Okay? Any other question about anything? I think there is no question. Evet arkadaşlar, haftaya Muharrem Hocam'ın da izniyle vize öncesi son hafta oluyor. Muharrem Hocam merhaba.
Merhabalar hocam.
Hocam sizin de izninizle arkadaşlara haftaya ders değil de soru seansı olacağını söylüyordum tam. Dersimi bitirdim.
Evet, elinize sağlık, dilinize sağlık hocam. Arkadaşlar katıldığınız için teşekkür ederim.
Kaydı durdurun isterseniz hocam siz.
Evet, teşekkür ederim arkadaşlar. Bana bir sorunuz var mı ders içeriği ile ilgili?
Yok
Evet,
herhalde
teşekkür
hocam.
ederim arkadaşlar. Ben kaydı durduruyorum.